Okay, so in this video, we are going to look into type 3 of permutations. Now, just to recap all that we have done so far, we have done an introduction of permutations and combinations. We've done type 1. Type 1 was when the position of one or more object was fixed. Type 2 was when two or more objects were to be together. Now, type 3, which we're going to look into today, and not just type 3, in fact, we're going to look into type 3, type 4, and type 5. So starting with type 3, in type 3, it's the opposite of type 2, where two objects are not to be together. Okay, so let's see how that works. So here's a question from past papers. Let's see what it says. It says the committee that is chosen consists of 4 men and 2 women. So remember, these are questions. They're not full questions. They're basically specific parts of questions. So this question says that the committee that is chosen consists of 4 men and 2 women. They queue up randomly in line for refreshments. Find the probability that the women are not next to each other in the queue. Okay, so one thing that's worth pointing out is that there are 2 women. So we have to make sure that these 2 women are not together, okay? So the way that we do this is that we first find out the number of ways that they can be together, and then we subtract that from the total. Okay, so 2 people can either be together, or if they're not together, that means they're not together, they're separated. So the way that we work this out is that we do total minus the number of ways that they're together. Okay, so 2 objects are not together, I should mention over here, is equal to total minus the number of ways they can be together. And we know the how to work out the number of ways they can be together. We did that when we were doing type 2. So let's work this out. How many people do we have? We have 6 people. So we'll start by making 6 blanks. 1, 2, 3, 4, 5, 6. Okay. So the 2 women who are supposed to be together, we're going to put them in a box. And because they're 2 people, that means they can shuffle amongst themselves 2 factorial number of ways. And then we have 1, 2, 3, 4, 5 people to arrange, 5 units basically, because these 2 women will now be treated as 1 unit. So that would be 2 factorial multiplied by 5 factorial. Let's work that out. Let's see what if we get. So 2 factorial multiplied by 5 factorial should be 240. Yep. So 240 is the number of ways that they are together. Okay, so let's find out the total number of ways. So if I want to work out the total number of ways, we can do that on the side. So the total would simply be 6 factorial, because we have 6 people. How can you arrange, or how many number of ways can you arrange 6 people? That is simply 6 factorial. We don't have to worry about repetitions or anything. So that is equal to what? That's equal to 720. So another way that you can do it, since we have to work out probability, you can find out the probability that they are next to each other and subtract that from the total, which is 1 in case of probability. Or you can just work it out directly, that the probability of the number of ways that they are not together is equals to 720 minus 240, total minus the number of ways they are together, divide by the total. So let's see, what do we get? So we have 720 minus 240 divide by 720, so we get 2 upon 3, and that is the correct answer. Okay, so 3 easy marks. All right, now another question from past papers. Let's see what this says. So it says here that Fahad has 4 different colored pairs of shoes, white, red, blue, black, 3 different colored pairs of jeans, blue, black, and brown, and 7 different colored t-shirts, red, orange, yellow, blue, green, white, and purple. Okay, then it says find how many different ways Fahad can arrange his 3 jeans and 7 t-shirts in a row if the 2 blue items are not next to each other. Okay, so we're talking about 10 different pieces, 10 different objects, and we have to make sure that the 2 blue items are not next to each other. So once again, the way that we're going to work this out is that we're going to first put them together and then subtract that from the total. So if you want to work out the total would simply be 10 factorial. Why 10 factorial? Because we have 10 objects. So how many ways can you arrange 10 objects? That is equal to, let's work this out. It's going to be a huge number, but don't freak out. Or in fact, let's just leave it as it is. Okay, let's not work it out. We can just work out the final answer. That way we won't have to write down such huge numbers over and over again. So let's find out the number of ways that they are together. Okay, so the following working that I will do will be to find out the number of ways that they are together. So the way we do that is that the objects that are not to be next to each other, we find out the number of ways that they can be together. We put them in a box. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's put them in a box. There we go. 2 factorial. Now what about the rest? Let's write this again. 2 factorial into 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of ways that they can be together is 2 factorial into 9 factorial. And if I want to find out the number of ways that they should not be together, we'll have to subtract that from 10 factorial. So let's work this out, see what do we get. 10 factorial minus, in a bracket, write 2 factorial, which is as good as 2, so you don't have to write factorial after 2, multiplied by 9 factorial. Let's see what that gives us. So like I said, gives us a huge value. And this is 2903040, which is the correct answer. 2903040. Okay, so this is 2,903,040. So these are the number of ways that the two blue items are not next to each other. Okay, now, next question. The back row of a cinema has 12 seats, all of which are empty. A group of 8 people, including Mary and Francis, sit in this row. Find the number of different ways they can sit in these 12 seats if Mary and Francis do not sit in seats which are next to each other. Okay, now do keep in mind that not all 12 seats will be occupied, only 8 seats will be occupied. Okay, so we will start by making 12 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's find out the number of ways Mary and Francis can be together. That would simply be 2 factorial. So let's do that. Then here's where you have to be careful. So 2 factorial multiplied by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 different units to arrange. But here's the thing. Are these all 11 different units? Because remember, there are 8 people. So the people will obviously, there are 6 remaining people after Mary and Francis are to be together. But that means there are 4 empty spaces. So every empty space is identical. So because we have 4 identical objects, we will divide it by 4 factorial. So think of it this way. Here's empty seat 1, here's empty seat 2, here's empty seat 3, and here is empty seat 4. So you can see that these 4 are identical, so we have to divide it by 4 factorial. Okay, now let's work this out, see what we get. So we get 2 factorial into 11 factorial divided by 4 factorial. So once again, it's a huge value, 3326400. So this is basically the number of ways that they are together, okay? Now we want to find out the number of ways that they are not together. So how do we do that? So we find out the total. Now, how many ways can you arrange 8 people in 12 seats? So the way that we will do that is 12 factorial, but remember, there are 4 empty seats which are identical, so we'll divide by 4 factorial. So 12 factorial divided by 4 factorial minus the last answer that we worked out. So we get, so total, I'll write this down over here, total minus together gives us the last answer that we worked out, which is equal to 1663200. So this is, let's see, 16,320,000. Sorry, 632,000. Yeah, 16,632,000, which is the correct answer. Okay, now another question. Let's see what this says. It says, find the number of ways all 10 letters of the word Copenhagen can be arranged so that the E's are not next to each other. So once again, pretty straightforward approach for a question like this also. Let's make 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we're talking about what? We're talking about E's that should not be next to each other. So let's put them in a box. So these E's, because they're identical, we're not going to say that they can shuffle amongst themselves. So we'll just write E and E. So even if you do 2 factorial, you will then have to divide by 2 factorial because they're identical objects, okay? And then let's talk about the remaining objects, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So into 9 factorial, but let's see if there are any repetitions. There must be. I can already see n is being repeated. Okay, so n occurs twice, so that means we'll have to divide by 2 factorial. P occurs once, O occurs once, C occurs once, A occurs once, H also occurs once. So this will give us the number of ways that the 2 E's are together. Now what we have to do is, we have to subtract the number of ways they're together from the total, and the way to work out the total would simply be 10 factorial. So because we have 10 letters, divided by 2 factorial because of the 2 n's, and also divide by 2 factorial because of the 2 e's. Okay, so total means without any restrictions, just like how you would solve any other question that we've done in the beginning. So if you work this out and if you do it correctly, you get 725,760 which is the correct answer. Okay, now, another question of the same type. Let's see what this says. An arrangement of the 8 letters in the word released is chosen at random. All right, find the probability that the letters A and D are not together. So how many letters are we talking about? We're talking about 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's put A and D together. Let's find out the probability of them being together, and then we'll subtract that from 1. So since we've solved a question similar to this, let's change the strategy a little. So let's put A and D together. 1, 2, 3, 4, 5, 6, 7. So we're talking about 2 factorial because A and D can shuffle amongst themselves. 2 factorial number of A's multiplied by 7 factorial. Now let's see if there are any repetitions. I can see E being repeated 3 times, so we'll have to divide by 3 factorial. R occurs once, L occurs once. We've already considered A and D. S occurs once. Okay, so this will give us the number of ways that they are together. So let's work this out. 2 multiplied by 7 factorial divided by 3 factorial, which is equal to 1680. Okay. Now what we're going to do is we're going to work out the total number of ways in which the 8 letters can be arranged. That would be 8 factorial divided by 3 factorial. Are there any other repetitions? No, there aren't. So let's put this in the center. 8 factorial divided by 3 factorial. Let's work this out, see what do we get. 8 factorial divided by 3 factorial, that's equal to 6,720. Okay, so let's find out the probability of these 2 letters being together. That would be the favorable outcome, which is 1680, divided by the total outcome, which is 6720. So 1680 divided by the answer. So we get 1/4. Okay, so this is the probability of together. Now the probability of not together would simply be 1 minus the answer. So the probability of not together would be 1 minus 1/4, which is equal to 3/4, and that is the correct answer. There you go. Okay, so I believe that is the end of type 3. Now let's focus on type 4. Okay, now first of all, understand the difference between type 3 and type 4. Now, type 4 says not all are together, okay? So what I'd like to do is I'd like to make some room here so I can explain to you what the difference is. So let's see if I can drag this down a little and drag this down a little. Okay, so let's say that we have 3 people, A, B, and C. And let's say we have 5 blanks, 1, 2, 3, 4, 5. Okay. So here we can see that all are together. Okay, here we can see that all are together. If let's say we do this 1, 2, 3, 4, 5. Let's say we have A here, and then we have B and C together. So at this point, we will not say that no 2 are together. We will say that not all are together. Okay, so essentially, this is the same as the previous type. If you want to find out the number of ways that not all are together, you find out the number of ways that they're all together and subtract that from the total. However, although this is type 5, which we're going to discuss later on, but if we do this, A, B, C. Now, how is this different from the previous one? Here we say that no 2 are together. That means they're all separated. Okay, so there's a difference. Make sure you understand the difference very well. The difference between all are together, the difference between not all are together, and the difference between no 2 are together. Not all are together means that you can have, if let's say you have 3, you can have 2 together. If let's say you have 4, you can have 3 together, but you can't have all of them together. No 2 are together means that they all must be separated. Now, how we separate them, we're going to talk about that in a minute, but for now, just remember that not all are together is basically worked out the same way, that is total minus together. Okay, so let's do a few questions of this category. Here's a question. Let's see what it says. It says the 9 letters of the word happiness are arranged in random order in a line. Find the probability that the 3 vowels A, E, I are not all next to each other. So that means they all shouldn't be next to each other. You can have 2 next to each other. That's acceptable. So first, let's find out the number of ways that they can be next to each other. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's make a box of 3. So the 3 vowels A, E, and I, since they're different, obviously, can shuffle amongst themselves 3 factorial number of ways. Okay, remember we're finding out the number of ways that they can be together, okay? Into 1, 2, 3, 4, 5, 6, 7. So into 7 factorial, but be careful. There are repeating letters. I can see P is being repeated twice. I can see S repeating. So yeah, that's it. No other repetition. Let's work this out. 3 factorial into 7 factorial divided by 4. So we're looking at 7560. Now let's talk about the total. So the total would be 9 factorial divided by P is being repeated twice. So 2 factorial multiplied by 2 factorial. Any other letter other than P and S that's being repeated? No, that's it. So let's work this out. So 9 factorial divided by 2 factorial into 2 factorial, that is 90,720. So let's find out the probability that they are together, and then we can subtract that from 1. So that would be 7560 divided by 90720. So 90720 I already have in my calculator. 7560 divided by the answer is 1 upon 12. And then to find out the probability of not together, we will simply have to subtract 1 upon 12 from 1. 1 minus 1 upon 12, which gives us 11 upon 12. And that, fellas, is the correct answer. Okay? So not that difficult if you understand the concept. And given that you don't skip any steps, you don't try to jump to conclusions, you don't come up with some weird standard rules or shortcuts, just do it the way that it's meant to be done. Okay, now the 11 letters of the word remembrance are arranged in a line. Find the number of different arrangements which do not have the 4 vowels. Now this question is slightly different from the previous one because the objects that shouldn't all next to be each other have some repetitions. Okay, so let's start by making 11 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 4 vowels. All right, here we have the 4 vowels. Let's write them down. E, E, A, E. Okay, so these 4 vowels can shuffle amongst themselves. 4 factorial divided by 3 factorial, number of ways. Okay, multiplied by, now 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial, but be careful. I can see some repetition. So first let's cross out the letters we've dealt with so we don't end up using them again. So I see R is being repeated twice. So that means we'll have to divide by 2 factorial. And I think, M is being repeated twice. So divide by 2 factorial. Okay, so let's work this out. So this, if you work it out correctly, you get 40,320. 40,320. Okay, now let's talk about the total. So the total would be an interesting value. 11 factorial divided by E is being repeated thrice, so 3 factorial. R occurs twice, so 2 factorial. M occurs twice, 2 factorial. Okay, now from this, from the total, if you subtract the number of ways that they are together, which we have worked above, this is, by the way, the number of ways that they are together. Okay, that's not how you spell together. So you get, I'm just going to write down the final answer to save some time, 1,622,880. And that is the correct answer. Okay, let's do a couple more. Find the total number of different arrangements of the 8 letters in the word tomorrow that have an R at the beginning and an R at the end, and in which 3 R's are not all together. So the examiner is just trying to make your life more and more miserable by adding more and more restrictions. Okay, but we can do this the exact same way. 1, 2, 3, 4, 5, 6, 7, 8. So let's start by fulfilling the first condition, which is that R must be in the first and the last place. Okay, and then the 3 O's are not all together. So that means we can find out the number of ways that they're together, which would be 3 factorial divided by 3 factorial. Okay, 3 factorial divided by 3 factorial. Now, we can't consider, so when we're talking about how we can arrange while keeping the 3 O's together, we're not going to consider this place and we're not going to consider this place. Why? Because they're fixed. And we can't swap the 2. Okay, it's not like the question says that has T on at one end and P on the other, which means we can swap the 2. So there's no other way that you can have the 2 R's on each end. It's just one way. Okay. So, however, we can shuffle these spaces. Okay, we can shuffle these units. So 4 factorial. Now, I've got to be careful. if there are any repetitions. So we've dealt with the R's, we've dealt with the O's. T, M, and O just occur once. That means we don't have to divide it by the factorial of anything. So 3 factorial divided by 3 factorial is just 1. 4 factorial, however, is 24. So this is the number of ways that they are together. Now let's calculate the total. This is, by the way, together. So the way that we're going to work out the total is as follows. Total would be, how many letters are we talking about? We're talking about 8 letters. And from these 8 letters, O occurs 3 times, so that's 3 factorial. R occurs twice, so that's 2 factorial, which is equal to 3,360. Now let's subtract 24 from 3,360. No, wait, I've done something wrong. 3,360 minus 24. Let's see what we get. 3,360 minus 24, so we get 3,336, which I believe is the correct answer. Okay, now, last question of this type, then we move to the next type. Okay, find the number of different arrangements of the 8 letters in the word deceived in which the 3 E's are not all together. So once again, we have to make sure that the 3 E's are not all together. So we start by making 8 blanks, 1, 2, 3, 4, 5, 6, 7, 8. So let's put the 3 E's in a box, E, E, and E. Okay, so these 3 E's can shuffle amongst themselves 3 factorial divided by 3 factorial number of ways into 1, 2, 3, 4, 5, 6. So into 6 factorial, what should I divide 6 factorial with? Let's see if there are any repetitions. So we've dealt with the E's, let's cross them out. Now I see D that's being repeated, so divide by 2 factorial. This is how we work out the number of ways they can be together. So let's see, 6 factorial divided by 2, that is 360. Okay, now let's work out the total. The total would be 8 factorial divided by 3 factorial into 2 factorial. Okay, let's see what that is. So we have 8 factorial divided by 3 factorial into 2 factorial, that is 3,360. Now 3,360 is the total from which if we subtract the number of ways that they are together, we get 3,000, which is the correct answer. There you go. Okay, now let's talk about type 5. Now type 5 is basically the type where no 2 are together. So if you recall, this is basically type 5. We have to make sure that whatever, if you're talking about people, if you're talking about objects, we have to make sure that they're all separated, okay? Now, once again, there's a standard way of solving questions like these, and if you follow this standard rule, I can guarantee that you will get, inshallah, every single question right, okay? So let's read this question, see what it says. It says, 4 families go to a theme park. If you remember, this is a question which I solved in, I think, type 2. Yeah, Mr. and Mrs. Lynn take their 2 children. Mr. O'Connor takes his 2 children. Mr. and Mrs. Emma take their 3 children. Mrs. Burton takes her son. The 14 people have all to go through a turnstile one at a time to enter the theme park. Okay, now here, the condition is, if no 2 adults go consecutively. How many different orders can the 8 children and 6 adults go through if no 2 adults go consecutively? Okay, so the way we work questions like these out is as follows. So we have to make sure that the adults are separated. So what is the one thing we don't have to worry about, or what's the one category we don't have to worry about? We don't have to worry about the children. So we start by making 8 spaces, or basically the number of spaces equal to the number of people we don't have to worry about being together. And that's the number of children. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we first talk about how we can arrange the people who no restriction is applied to. That's the children. Okay, now since we have 8 children, so that means as far as the children are concerned, they can shuffle 8 factorial number of ways. There's no restriction, nothing to worry about. Okay, but as far as the adults are concerned, because no 2 adults want to go together, then that means there has to be a child in between. So if there's an adult, there's got to be a child. If there's an adult, then there's got to be a child. Okay, an adult, maybe 2 children. So what shouldn't happen is that you shouldn't have an adult follow an adult. Okay, so that means the places where we can have the adults are in between the children that we have already. So let's count the number of spaces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means we have 9 spaces. And how many adults do we have? We have 6 adults. So how do you arrange 6 adults when you have room for 9? The way you do that is simply 9p6. Okay, and that's it. That's your answer. So let's work this out. 8 factorial multiplied by 9p6. What do we get? Okay, we get a freakishly large value, but don't worry, this is the correct answer. So it's 243,855,3600. Sounds like someone's phone number. So let's see what this is. 3 digits, comma, 3 digits, comma. So it's 2,438,553,600. Okay, but that is the correct answer. Okay, and this is how you do questions like these. So I repeat, I'll give you a summary. So we have to make sure that no two adults go consecutively. So that means we don't have to worry about the children going consecutively, or we don't just have to worry about the children at all. So we start by placing the children. So we have 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. So therefore 8 factorial. Then the adult has to be positioned in such a way so that there is a child in between. And the way we can do that is that we have 9 options, okay? And from the 9 options, or from the 9 spaces, we only have to use 6, okay? Or we have to arrange 6 adults, and we have room for 9. So the way we do that is 9p6. And that's it. Job done. Let's do another question. If you didn't get the hang of it the first time, that's all right. Let's do another one. Let's see what this one says. A town council plans to plant 12 trees along the center of a main road. The council buys the trees from a garden center, which has 4 different hibiscus trees, 9 different, okay, I don't know how you pronounce that, certain trees, and 2 different oleander trees. Okay, the council buys 4 hibiscus, 6 J, I'm going to call them J, and 2 oleander trees. Okay, how many different arrangements of these 12 trees can be made if no hibiscus tree is next to another hibiscus tree? Now, because we have more than 2 hibiscus trees, so that means we can't use the total minus together approach here, okay? If, let's say, there were 2, or if, let's say, we were doing this for oleander trees, we could have done that. So we have a total of 12 trees, so we're not going to make 12 blanks. We have to make sure that there is no hibiscus tree next to another hibiscus tree. So other than hibiscus, how many trees do we have? We have 8. Okay, so we start by making 8 blanks. 1, 2, 3, 4, 5, 6, 7, 8. And these 8 trees, there's no restriction on them, so that means we can shuffle them 8 factorial number of ways, okay? Now, wherever we place the hibiscus tree, we have to make sure that there is some other tree in between the 2. So that means we can place one here, 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 or here. So altogether, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have room for 9, and how many do we have to place? We have to place 4. So that means 9p4. So if you work this out, and once again, if you work this out correctly, you'll get a freakishly large value, 121,927,680. There you go. That is the correct answer, whether you believe me or not. Okay, now question number 3. There are 10 spaniels, 14 retrievers, and 6 poodles at a dog show. 7 dogs are selected to go through the final. 2 spaniels, 2 retrievers, 2 poodles go through the final. They are placed in line. How many different arrangements of these 7 dogs are there if no poodle is next to another poodle? Okay, so it's the poodles that have a problem, right? So that means these 4, that is 2 spaniels and 2 retrievers, don't have a problem. So what do? We first place them. We first arrange them 1, 2, 3, 4, and they can be arranged 4 factorial number of ways. Now, where can we have a poodle? We can have a poodle here, we can have a poodle here, 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 or here. So altogether, we have room for 5, and we only have to arrange 3 of them. So 4 factorial multiplied by 5p3, which is 1440. And there you go. That's the answer. Okay, one last question. Let's see what this says. Find the number of different ways that 6 boys and 4 girls can stand in line if no girls stand next to another girl. Okay, so it's the girls that have a problem. That means we first arrange the boys, 1, 2, 3, 4, 5, 6. And the way we can do that is 6 factorial number of ways. Now, how many options do we have for the 4 girls? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 options. And how many girls do we have to arrange in these 7 places? Only 4. So 6 factorial into 7p4. And if you work this out, you get 604,800. Yeah, 800, not 880. And that's it. That is basically type 5, where you have to make sure that no 2 are together. So we're only left with 2 types now. Type 6 is where you have to arrange in different rows and columns. And type 7 is where you have permutations applied to numbers. Okay, so that's a separate category altogether. I'm going to do that in the next video, inshallah. But I hope this, whatever we've done as far as permutation is concerned is clear to you guys now. If you have any suggestions, anything you want me to cover, let me know in the comment section. If you got till the end of this video, congratulations. I'd like you to leave this emoji so I can make sure whether you have gotten to the end of the video or not. So that's it for this one. I'll see you guys in the next one. Until then, take care. Bye-bye.